Well, hello again, everyone. For this video, we want to talk about the concept of pitch. Now, I've put a blank staff up here in front of you, and let me do some basic explaining here before we get into the acoustical properties of pitch and why that's such a big deal. If you look at the staff here, it has 5 lines, 2, 3, 4, 5, and 4 spaces. Now, those 5 lines are simply reference points. When you make a decision to assign a clef, which is what we see here, this is the treble clef, to the staff, now all of a sudden we have a point of focus. As a treble clef staff, this is sometimes referred to as a G clef because it tells you where G is. If you look at the design of the clef, you can see how it circles around here. This little last circle, this little curlicue here, is centered around this second line from the bottom, the 4th line down. And we say that this clef then tells us where G is. There are other clefs, of course. Finale has a clef tool built in. I can show you some different clefs here. For example, if we come down here to where it says measure 4, if I click on this, we'll start with the most common clef, the bass clef. And the bass clef is sometimes referred to as an F clef because it shows you where F is. The sort of tail right here, the little fat part, and then the 2 dots surrounding the line. So the second line from the top here shows where F would be, and specifically F3, but we'll talk about why this is F3 in a few minutes. There are other clefs, of course. We could turn this into an alto clef, and let's take a look at the alto clef. Now, if you're a violist, you've seen alto clef for quite some time and you haven't thought twice about it. But for those of us who aren't in that world, this may be a different experience for us. This is referred to as a C clef because the little point where the 2 round structures meet, and that little arrow that's formed there, is supposed to indicate where middle C is, also known as C4. And this line right here in an alto clef, the middle line is middle C. So this is middle C, and then everything above that is above middle C. Everything below that line is below middle C. Now, if you're a viola player, I said you've seen this before, and the reason alto clef works so well for viola is if you think of how the viola is laid out, where most of its range is, using alto clef allows you to do this without a whole lot of ledger lines, which we'll talk about ledger lines later on as well. There's also the tenor clef, which is also a C clef, but raised up 1 line, so now the second line down from the top is C, middle C. And there are some other clefs as well. Those are the 4 most common. The G clef, used for treble clef, the F clef, used for bass clef, and then C clef, used for either alto or tenor clef. You might see things like this periodically. Move a C clef down here. This is what's called the soprano clef, where middle C is the bottom line. There's also the mezzo-soprano clef, up through alto, and then occasionally you see this. The C is the top line. This is sometimes referred to as the baritone clef, and there's also baritone clef can also be shown as this. This looks like a bass clef, but it's down a little bit. And both of these would produce the exact same pitches, because remember, this is an F clef. This shows you where F is, whereas this is a C clef. It shows you where C is. If C is here, F is going to be there. Conversely, if F is there, C is going to be there. So it's 2 different ways of doing the same thing. Let's go to just a treble clef here. Now, in terms of pitch names, there are 7 essential pitch names. And it's like the old Hooked on Phonics ad, A, B, C, D, E, F, G. It's interesting that we start our pitch numbering or pitch lettering with A, but when we think of a neutral key, it's the key of C. There are no sharps or flats in it. So let's put middle C up here. Right, this is middle C. I think we're all willing to accept that. In bass clef, should we get a bass clef system going here? middle C is right there. Now you'll notice if I played them, listen to them again, pitches were exactly the same. This is also C, although it's a C that is what we call an octave higher. Now, if you're in this class, chances are you are familiar with the basics of pitch and why they're labeled as such. Let me explain the whole octave thing to you if that's never been explained to you. In the case of an octave, it simply means that the means of sound production, whatever that is vibrating at twice the speed of another pitch. When you're in an instrumental ensemble, for example, and the oboe player gives the A that tunes the orchestra, that is referred to as A equals 440. And what we mean by 440 is 440 hertz, H-E-T-R-Z, or abbreviated H-Z. Hertz is just a unit of measurement meaning cycles per second. And by cycles, see if we can do this. This is rather inartful. I'll make sure to put it on the board. We can talk about it in some more detail. But if you were to pluck a string, that string vibrates back and forth. And the number of times it vibrates back and forth per second is what creates its pitch. That can be plotted on a graph where you can kind of see, plot over time, how far out it goes and then how far back the other direction it goes before returning to the 0 point. Well, something at the pitch A440 is vibrating 440 times a second. That whole up and down, back and forth thing will happen 440 times in the space of a second. So in the time it takes for this to happen, that sound producer has vibrated back and forth 440 times. If I go an octave above that, notice use of the ledger line here. Let's get rid of this weird clef thing here. If I go an octave above that, then this particular A is now vibrating at twice the speed. So what's 2 times 440? 880. And another A down here an octave below, for example, would be vibrating at half the speed, so 220. Now here's the thing. If we were to always refer to this A here as A440, and this is A880, this is A220, that's fine. That's an easy math problem to do if you're trying to do multiples or halves of that particular number. But because of how the frequencies work, C is a very odd number. It would be something like 563.7. So while we can call this A440, calling it C 563.7 or whatever it is would be awkward and inelegant. So we've come up with a system, and it relies on knowing the difference between pitch and what we call pitch class. We have 5 distinct pitches up here. This C, and these 3 A's. Those are 5 distinct pitches. These 2 pitches do not sound exactly alike. No 2 pitches sound exactly alike, I should say. But anytime you have this octave ratio, these are all A's. They are just different iterations of A. A880 is an octave higher than A440. A220 is an octave lower than A440 and 2 octaves lower than A880. So we've come up with a different system to help us out here. And that particular system is referred to as octave placement nomenclature. That's a fancy way of saying we give the pitches distinct names based on what octave they're placed in. So our old buddy middle C back here is C4. Now the reason it's C4 instead of C0 or C1 is because that there's a good amount of space underneath it and we want to have some room available. And C is always our starting point. Again, this is one of the vagaries of music notation, is that our letter names begin with A, but so much of what we do is based around the idea of C. So this would be C5. I can tell you that A440 is also known as A4, so see if you can guess what this A would be up here. That's right, A5. Now if this is A4 and this is A5, what do you think this A down here is going to be? A3. Each one of these pitches, C4, C5, A4, A5, A3, are distinct pitches. But because the C's have this octave relationship and each of the A's has this octave relationship, we say that every C is a member of the pitch class C. Pitch class is sometimes abbreviated PC. Every A, be it A4, A5, A3, even put A2 and A1 on here for you. A2 would be down here. A1 would be down here. And then all the way at the bottom of the keyboard. Not even sure I can. This very bottom note here would be A0. The bottom notes on the keyboard are the 0 notes, just because not all keyboards originally had those notes. So we have A2, A1, and A0. And conversely, if we have A4 and A5, we can also have A6, A7. I'm going to need a little more space here to make this work. A8 does not technically exist on the keyboard. The highest note on the keyboard is A7, or is a C8. That's starting the cycle over again. But these are all the A's, and all A's are said to be members of the pitch class A, even though each one of them is a distinct pitch. Think about your family. If you share a last name, you're all distinct people, but you're all within the same family. So that's one way to think about this. Each of these pitches is a distinct pitch, but they're all within the same family of A's. So that's the basics of pitch and pitch class at this point. In class, we'll spend some time talking about chromatics and why A flat and A are two different notes and how we notate these things. But this is a good starting point, I think. So we'll go on from there. Thanks for watching as always, and have a great day.